Hello, my name is Will, and this is my report for Physics 2, Lab 1. First, I'd like to do a quick overview of the lab and think about our objectives. So this lab consisted of two parts. In the first part, I conducted an experiment by charging tape and floating one on top of the other. Using the distance between the floating tape and the non-floating tape, I was able to calculate and solve for the charge of the tape. Next, I used the same data to calculate the electron deficit and electron to atom ratio. The charge I calculated can be seen on the slide. In the second part of this lab, I was tasked with modeling the same experiment in GlowScript. This included modeling both tapes as point charges and modeling the forces acting on the floating tape. This way, I could conduct the experiment in an idealized scenario to compare with my own experience. The main physics principles used in this lab is the electric force. This formula also consists of the electric field formula. After finding electric field, you can multiply by the charge of the object and find its force. Newton's first law was also implemented in this lab. This was used to determine the gravitational force acting on the upper tape. Essentially, in the experiment, it was found that the net force on the y-axis of the floating tape was zero, with the electric force being equal and opposite to that of the gravitational force. Because the charge was the only missing variable, we were able to set the equations equal to each other and solve for our charge. The experiment portion of the lab consisted of three parts. In part 1, we tested how a U-tape interacted with different objects. A U-tape is a piece of tape that is charged after quickly pulling it from a base tape. I found the U-tape was attracted to neutral objects, which helps support that it is in fact charged, as a charged object would polarize neutral objects in a way that would cause attraction. In order to determine the sign of the charge, I tested it against a known negative charge, such as plastic through hair, and found that it was attracted. This means the U-tape held a positive charge. In the second part of the experiment, I used one U-tape to float another. The purpose of this was to find the charge of the U-tapes. By floating one, we could determine its electric force was equal and opposite to that of the force of gravity on the y-axis. This allowed us to set the two equations against each other and solve for the charge. In part 3, I used a few calculations, I completed a few calculations such as the number of atoms on the surface of the tape, the electrons removed from the tape, and the ratio of electrons to removed atoms, or the ratio of electrons removed to that of the atoms. The answer to those calculations can also be seen on this slide. For the second part of the lab, I modeled the floating tape interaction in GlowScript. For my constants, I needed the value of 1 over pi epsilon 0 and a scale constant so that the arrows I use later would be visible. First, I created my objects and locked in their values. The most important parts were their locations relative to each other on the y-axis and the mass of the top tape. The mass of the top tape was calculated using the formula in the lab instructions relating the length of the tape to its mass. I also went ahead and used the distance between them to calculate the charge on the tape and assign it to each tape. In this lab, we decided to assume that each tape had the same charge. I will get into this later. Next, I utilized the function created in Lab 0 to find the electric field on the upper tape, and then used that to find the electric force. I then used the mass to find the gravitational force, and finally the net force, which is the combined gravitational force and electric force. In this scenario, we only need to look at the y-axis, but for the purposes of this experiment, we didn't even consider any forces on the x or z axis. I then used arrows to represent the force of gravity and electric force. As you can see in the visualization, the arrows are equal, putting the upper tape at an equilibrium. The magnitude of charge emitted is also seen on the visualization screen as requested, and is very similar to the value I calculated by hand. Next, I would like to do some critical analysis on the lab. In this lab, we assume both charges on the tapes are equal, as they are ideally identical and undergo the same process. This means that ideally both pieces of tape would be the exact same length with the exact same handle length and would both undergo the same charging process when you rip one from the other. We also assume that the electron deficiency is constant and not something that is constantly changing. It is likely that the deficiency calculated is quite different to that at its initial charging due to environmental sinks. One thing that was mentioned in the lab instructions was humidity, which could possibly affect the attractiveness or the charge of the pieces of tape. As a charged object touches an oppositely charged object, it is leaking or stealing electrons over time. If electrons and protons were to flip, it is likely the results of the lab remain mostly identical. Same values would still continue to repel each other, while opposites would still attract. In this lab, we handled the tape as little as possible in order to prevent the tape from losing its charge. The tape can lose its charge by coming into contact with other objects. It is possible that our body could be slightly charged, changing the results. This is also a potential source of error, as if we could artificially change the charge of our tape the longer we delay the experiment and the more it is exposed to potential electron sinks. Thank you for watching.